Alright, so in this problem, I have 3 to the power of x is equal to 80. So, I want to find the value of x here. So for my solution, I first start with 3 to the power of x is equal to 80. And now, I'm going to take the log on both sides. So I get log 3 to the power of x is equal to log 80. Now, we want to find a way to, we want to find the value of x, right? And to get x, it's hard to do it when it's in exponent form. So we want to find a way to bring x down to make it a real term. And to do that, there is an important property of logarithms that states that if there's something in the form log a to the power b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So now I have x times log 3 is equal to log 80. Now from here, I'm going to rewrite 80 here as 8 times 10. And if I have something in the form log a times b, this is equal to log a plus log b. And this is another one of the logarithmic properties. There is also log a over b, and if I have something in this form, this is the same thing as log a minus log b. So now going back to the problem, we have log 8 times 10, and we can use this property. So we can think of 8 as a and 10 as b. So this is going to equal x log 3 is equal to log of 8 plus log of 10. Now, if you guys already didn't know, log 10 is simply equal to 1. So I get x times log 3 is equal to log 8 plus log 10. Or sorry, just 1. And now remember, we want to isolate x, so the only thing left to do is to get rid of this log 3 by dividing both sides by log 3. So then this cancel out, and I get x is equal to log 8 plus 1 over log 3. Now, log 8 is equal to 0.90309, and log 3 is equal to 0.4771. So this is going to equal 0.90309 plus 1 over 0.4771. And this is equal to 1.90309 over 0.4771. Now 1.90309 over 0.4771 is equal to 3.9889. So x is equal to 3.9889. Now, the only thing left to do is to check if my solution here is correct. So the original equation was right here, 3 to the power of x is equal to 80. And my solution is x is equal to 3.9889. So if I plug this in for x into my original equation, I get 3 to the power of 3.9889 is equal to 80. Now 3.9889 is really close to 4, right? So let's first find the value of 3 to the power of 4. 3 to the power of 4 is the same thing as 3 times 3 times 3 times 3, which is the same thing as 9 times 9, which is equal to 81. Now 3.9889 is a little less than 4, meaning we can estimate that it's going to be around 1 less than 81. So it's safe to say that 3 to the power of 3.9889 is close to the value of 80. Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So if I subtract 10 on both sides, these two cancel out, and I get x to the power of 3 plus x minus 10 is equal to 0. Now, from here, to actually find all of the solutions for this equation, we have to first start by finding one solution and then use that one solution to find the rest. So how are we going to find that one solution? Well, we're going to simply have to guess. So let's start with x equals 1. When x equals 1, I get 1 to the power of 3 plus 1 minus 10, and this is equal to negative 8, which does not equal 0. This is wrong. Now let's try x equals 2. When x equals 2, I get 2 to the power of 3 plus 2 minus 10. 2 to the power of 3 is 8. 8 plus 2 is 10. 10 minus 10 is 0. So this works. So now that we have one solution of x, we can use this solution to find out the rest of the solutions. And how are we going to do that? Well, if x equals 2, this means that x minus 2 is a factor of our original equation, because if we plug in 2 for x minus 2, that equals 0. This means that I have to divide x minus 2 with x squared plus x minus 10. However, this also means what we can do is we can rewrite x to the power of 3 plus x minus 10 as, well, what's 2 squared? 2 squared is 4, so I get plus 4x, and then because we have plus 4x, what is x? What is 4x plus what is equal to x? Well, 4x minus 3x, or we could also do 5x minus 4x. So we get 5x minus 4x minus 10 is equal to 0. Now, what I'm going to do is I'm going to factor by grouping. So we can group x to the power of 3 plus 5x and negative 4x minus 10. Well, x to the power of 3 plus 5x, the greatest common factor is x. However, this won't work because x squared plus 5, that can be simplified. So what I'm going to do is rewrite this as x to the power of 3 minus 4x plus 5x minus 10 is equal to 0. So now, if I factor by grouping, the greatest common factor from x to the power of 3 minus 4x is x, so I get x times x squared minus 4, plus from 5x minus 10, the greatest common factor is 5. So I get 5 times x minus 2 is equal to 0. Now x squared minus 4, I can rewrite that as x plus 2 times x minus 2. And I have this plus 5 times x minus 2 is equal to 0. Now from here, I can factor out x minus 2, so I get x minus 2 times x plus 2 plus 5 is equal to 0. And this simplifies to x minus 2 times x squared plus 2x plus 5 is equal to 0. Now this gives me two equations. I get x minus 2 is equal to 0, and I get x squared plus 2x plus 5 is equal to 0. Well, for x minus 2 equals 0, I can simply add 2 on both sides, so I get x equals 2. And we already got the solution by guessing at the start. Now for x squared plus 2x plus 5 equals 0, I can use the quadratic formula. So in this case, I get negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c all over 2a. And this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16 over 2. And you can't take the square root of negative numbers, so there's no solution for this, meaning my only solution to this equation is x equals 2.